Hello everyone, we are going live to take a look at reviewing pre-calculus and algebra, answering your questions about pre-calculus and algebra. We are going to just give one moment so that everybody who's logging in right now can log in and make sure they can join us. I'm excited to have you here. Make sure you're telling me where you're joining me from, how your algebra class is going, how your pre-calculus class is going, and I'm going to be really curious what questions you have so that we can take a look at them today during this live. Excellent. So I'm waiting for my Instagram to go live, and it's not working for some reason. I wonder if I typed the stream key in wrong. That's interesting. All right, looks like we're going to do it without Instagram this time because the stream key is not working, but that's okay. We are going to go live here to answer your questions for pre-calculus. So big hello to everyone who's rolling in right now. Welcome to our live office hours for pre-calculus and algebra, brought to you by Chegg. I'm at Wallace. You probably recognize me from my channels on TikTok, Instagram, YouTube, Twitch, and more. I do trends and memes about mathematics, so come from the humor and stay for the math. It's a great channel. Check me out there. But for those of you that have joined us here with Chegg in the past, I'm excited to have you back for more. For those of you that are here for the first time, the goal today is to help you understand your pre-calculus and algebra classes a little bit better. We are here every week to do just that. If you want to know the schedule of when we're going to be live, make sure you scan this QR code in the corner, and that way you can stay up to date on all of the virtual office hours we're doing here with Chegg. We are doing algebra, trigonometry, pre-calculus, calculus, linear algebra, there's chemistry, economics, so many more. So make sure you scan the QR code. Make sure you don't miss anything along the way. But anyways, I am here to help you in your classes, so don't be shy. Drop your questions in the chat for pre-calculus and calculus, and we're going to do our best to answer them throughout this hour. We're going to start off with, though, doing a little bit of completing the square, working with conic sections. Conic sections are a classic topic of pre-calculus. Let's take a look at this conic section. We're going to start with 4x squared minus 16x plus 9y squared plus 18y, and that's going to equal 11. And we're going to put this in standard form for a conic section so that we can get an idea of what shape it is, how big it is, and what it's doing. So first thing we want to do is make sure we group the x's together and group the y's together. This one's nice that it's already done that with the number on the other side. Once we've done that, we need to get rid of whatever's in front of x squared and whatever's in front of y squared by simply factoring both of those terms out. So we'll factor out the 4, leaving behind x squared minus 4x. We'll also factor out the 9, leaving behind y squared plus 2y. And we're still equal to 11. So that takes care of the a that gets in the way. The next thing we want to take care of, though, is we want these binomials to factor to a perfect square trinomial, which means we need to complete the square or find out what's missing to complete this value so that it's a perfect square. The way we find that value is we're going to take half of the middle number and square the answer. So we take half of 4, which is 2, and 2 squared is 4. So we're going to add 4. Of course, to stay balanced, whenever you do something to one side of the equation, you have to do the exact same thing on the other side of the equation. But something to remember is this 4 is inside the parentheses, which means it's also getting multiplied by this 4 outside. So it's actually 4 times 4. For the second one, we're going to do the same thing. We're going to take half of the middle term. Half of 2 is 1. And then we square the 1. 1 squared is 1, so we're going to add 1. And if we add 1 on the left side, we also have to add 1 on the right side. But again, remember, it's actually multiplied by the 9. When we do that, we still have the 4 out front. But then what's left here with the x's is a perfect square. We can take the square root of the first term, which is x. We can take the sign from the middle and the square root of the 4, which is 2. And now it's perfectly factored. Plus 9, then it's going to be something else squared. Again, we take the square root of the y squared, we take the sign from the middle, and we take the square root of the 1, and now it's factored. On the right side, it's just a little bit of arithmetic. We've got 11 plus 16 plus 9, 10, 16, 36, I think. If my mental math is correct and my chicken scratch is correct. By the way, if my arithmetic has an error in it, make sure you tell me what's going on and I can go back and fix it. But I think that's good there. Conic sections are usually equal to 1. There's a few exceptions, but most of the time they're equal to 1. So to make this one equal to 1, we're going to divide by 36 so that this reduces to 1, which means we're going to have to divide by 36 all the way across. And when we do, 4 over 36 is going to reduce to 9. So we have x minus 2 squared over the 9. Plus 9 over 36, that's going to reduce to a 4 in the denominator. And we've got y plus 1 squared. And that's equal to 36 over 36, which is 1. And hopefully you can recognize this as the shape of the conic section that is an ellipse. So if we wanted to graph this ellipse, graphing this ellipse, we go in the x direction. Actually, I need to shift my center. That might not, I might have to add to my graph. My center has to shift to the right 2 and down 1. Remember, we move opposite what's expected when we're in the parentheses. So I'll move to the right 2 and down 1. That's going to be the center of my ellipse, which means I'm going to need to make my graph go a little bit further. Underneath x, we can see how far we're going to go in the x direction. It's the square root of 9, which is 3. So we're going to go 3 to the left and 3 to the right. And those are going to be the ends of my major axis on this ellipse. To decide how far up and down we're going to go, we're going to take the square root of the 4. So we're going to go 2 up and 2 down. And those are the endpoints of the minor axis. And then I can connect them and make my beautiful ellipse. If I wanted to find the focus, where the focus is located on either side of this, the way we find the focus is we take the b squared and subtract the a squared. So 9 minus 4 is 5. And then we can take the square root of both sides. So c is the square root of 5, which is a little bit more than 2. So it's a little bit more than 2 this direction and a little bit more than 2 this direction. These are the foci. And the foci are really important in applications. For one example is you might know that the planets orbit the sun, not actually in a circular form, but in an elliptical form. And it turns out the sun is at one of the foci of the ellipse, which is kind of cool. Excellent. Well, let's continue working through some pre-calculus and algebra problems, answering your questions. I see a question in the chat about systems of equations. So let's bounce over to systems of equations and do one of those. With the system of equations, I don't know if you're doing substitution or elimination or even by matrices. Let's look at both methods, shall we? Let's do x plus 2y equals, let's see, I want to make sure I get a problem that works. Let's make that equal to 8. And let's do 3x minus y is 3. There we go. Hopefully I did my math right, and we can take a look at how we're going to solve this one. Let's solve it both ways so we can kind of see how the two ways compare. One way we can solve it is by substitution. The idea of substitution is we need to find the lone variable, a variable that has nothing around it. Notice that x has nothing with it. What we're going to do is we're going to get that x alone by getting the 2y off to the other side. So we'll subtract 2y from both sides, and we find out x is equal to 8 minus 2y. If I know x is equal to 8 minus 2y, I can replace x with 8 minus 2y in that other equation. So when I do that, we end up with 3 times x, which is 8 minus 2y, and then subtract a y, and that should still equal 3. And that gives me an equation that hopefully we can use to solve for the y. Let's distribute the 3. gives us 24 minus 6y minus y equals 3. I'm going to combine like terms. 6 minus 1 is negative 7y, but I'm also going to subtract 24 from both sides. So we'll take 24 over to the other side. 3 minus 24 is negative 21. Divide both sides by negative 7, and we find out y is equal to 3. Once we know that y is equal to 3, we can go back to this x equals equation and figure out what x actually equals. We can say x is equal to 8 minus 2y's, or 8 minus 2 times 3, or x is equal to 8 minus 6, or x is equal to 2. And so we have solved this system of equation using substitution by finding one variable that's all alone with nothing on it, solve for it, so that we can plug it into the other equation. Now, that's substitution. The other method that we have is called elimination. And let's get rid of these markings on here so that we can do elimination up here. The idea behind elimination is we want to get a positive and a negative in front of one of the variables. So if I wanted to pick on the x's, maybe I'd want to get negative 3 and positive 3 so that they're in front of the x's like that. Or if I wanted to pick on the y's, maybe I want positive 2 and negative 2. So that way they subtract out to 0. And that's kind of what we're looking for here. Since we've already got the negative here and the positive here, let's make the y's have opposites in front of each other. So I'm going to multiply this first equation by 2 on both sides. Because when I do that, we'll have negative 2y and positive 2y, which will add to 0. That's our goal with elimination. So the first equation's unchanged. X plus 2y equals 8. The second equation, when I distribute the 2 through, is going to give me 6x minus 2y equals 6. And that's nice because now I can add the 2 together. 6x plus x is 7x. 2y minus 2y is 0. And 8 plus 6 is 14. Divide both sides by 7, and x is equal to 2, which is the same value for x we found using that substitution method. Now, once we have x, we can go back to either of the original equations. Let's just go back to the top equation and plug 2 in for the x. So we've got 2 plus 2y equals 8, and that gives me an equation we can use to solve for y. If I subtract 2 from both sides, we get 2y equals 6. Divide both sides by 2, kind of run out of space, so I'm going to come over here. But if we divide both sides by 2, y equals 3, which is the same value for y that we found using the substitution method. So both methods work. Both the substitution method and the elimination method work excellent in order to solve. Tell me in the chat, do you have a favorite method? Do you like substitution or do you like elimination better? Sometimes the beginning of elimination is easier, but the end of substitution is easier. So there's kind of benefits and pros and cons to both. Which method do you like? Maybe you like graphing. Or what about matrices? There's lots of different ways to get there. Excellent. Well, what other topics do you want to take a look at? Absolute value inequalities from Evelyn on TikTok. Yeah, let's do absolute value inequalities. Those are a great topic because they really force us to look at understanding what's happening when we set up that compound inequality in order to solve. So again, this is your review session, your office hour about pre-calculus and algebra. So take a moment to put in the chat, what are you doing in your classes? Tell me what you're doing so we can do questions, examples, and problems just around that using the topics of pre-calculus and algebra. If you want to see derivatives and antiderivatives and integrals, tomorrow at 4:15, I think, we're Pacific time, 7:15 Eastern time, we're going to do a calculus study session. So come back tomorrow for calculus. Today is algebra, and we're going to do some absolute value inequalities. We're going to do 4 plus 3 times the absolute value of x minus 1 is less or greater than or equal to 10. Actually, we'll do 2 problems just so we can see the comparison. Let's also do 10 minus 3, absolute value of x minus 2 is greater than or equal to 4. These look very similar, but there's actually a key difference between the two, and we'll talk about that and why you need to be able to know those differences. First thing we want to do on any absolute value problem is if the absolute value is not alone, we need to solve to get it alone. So we've got this 4 plus 3 times the absolute value. We need to get rid of the 4 by subtracting 4 from both sides. That's going to give us 3 absolute values of x minus 1 is greater than or equal to 6. Notice I did not combine these to get 7. That's a really common error we see. We don't want to combine those to get 7 because the 3 is multiplied by the absolute value. The 4 is not. They are not like terms, so you can't combine them. So we have to subtract the 4 out separately and then divide by the 3 separately to get that the absolute value of x minus 1 is greater than 2. And yes, I emphasize that it's greater than 2 because the word greater tells me what I want to do. Greater means I'm going to set up an or because the absolute value is greater than the number 2. So I'm going to set up this x minus 1 is greater than 2. And then I'll say or. We'll say the x minus 1 and we'll flip the inequality and say it's less than negative 2. Those are our two options. And then that gives us equations we can solve from there by adding 1 to both sides. X is greater than 3. Or adding 1 to both sides, x is less than negative 1. Some of your teachers might want you to put your final answer into interval notation. This negative 1 is smaller, so less than negative 1, that's going, well, let's draw a number line and think about this. Actually, that might make it easier to see. So we've got negative 1s over here and 3s over here. This first one says we want numbers that are bigger than 3. Oops, I lost my or equals. Did anybody else notice that? It was or equals, or equals. It should be or equals all the way down. Sorry about that. Or equals all the way down. Or equals is important because that's going to give me a solid dot at 3. Let's do a different color just to really emphasize what's happening. Let's go ahead and do black so we can see it. Solid dot at 3. And I want bigger numbers. Bigger numbers are off to the right. We're going all the way off to the right, really to positive infinity. Less than or equal to negative 1, we've got a solid dot at negative 1. And then less than or equal to, we're going smaller values all the way down to negative infinity. So if I wanted to put this in interval notation, which most of your teachers probably want to see, we're going to go from negative infinity to negative 1 with a square bracket at negative 1 because I got the solid dot. Infinity, we can never actually get there. Infinity always is going to be a curved bracket. To do this jump, we're going to do a union. That union means I jump over that gap. And then we're going to go from 3 up to infinity. So everything's in order, just like the number line. That is our solution to the first one, where we end up with the absolute value being greater than the number. That gives us the or. Now, I mentioned this other problem looks really similar, but it's actually not. Because when I solve it using much the same strategy, again, we want to get the absolute value alone. We cannot do 10 minus 3 because the 3 is multiplied, the 10 is not. So we'll subtract 10 from both sides. That's going to give me negative 3. Absolute values of x minus 2 is greater or equal to negative 6. Then we're going to divide both sides by negative 3. And this is really important. We've got the absolute value of x minus 2. When we divide by a negative, if you multiply... Excuse me, I've got one of these pens that just sets my allergies off. It's the brown. Brown's the worst smell. Anyways, when we divide by a negative, the inequality symbol needs to flip directions. So now it's less than or equal to. Because we divided by a negative, 6 divided by 3 is 2. Notice this is different because now the absolute value is no longer greater like it was before, but it's actually less than. When it's less than, we're going to set up an inequality where the x minus 2 is in the middle of the negative version and the positive version. We set up a 3-part inequality, a tripartite inequality is what's that really called. So that's what we want to end up solving. So when I add the 2 to get the x alone, I have to add the 2 to all 3 parts. It's a tripartite. all three parts. So -2 plus 2, it doesn't go away. It's still 0. You're always going to have three parts. -2 plus 2 is gone. We're just left with x in the middle. And 2 plus 2 is 4. And this makes it probably easier to see that interval notation we're going after, because the number 0, x is somewhere in between, and the number 4 kind of just builds that interval notation that we're looking for right there. So great question about those absolute value inequalities. The big thing you need to keep track of is if the absolute value is greater, you set it up with an or less than the negative. If the absolute value is less than, you need to set up this three-part inequality with the negative on the left and the positive on the right. The other thing to remember, and we talked about a little bit, is when you multiply or divide by a negative, make sure you flip that inequality sign, change that direction. All right, this is your pre-calculus review session. Let me know in the comments what topics you're doing in your pre-calculus class, what topics you're doing in your algebra classes. What do you want to review, see examples of? Do you have a specific problem that you're having troubles with? Stick it in the chat, and I am here to answer those questions every week. And if you want to know more about the schedule of our tutoring sessions, scan that code. We at Chegg are here to help you 24/7 with your toughest subjects with many different resources, including these lives. So check that out. One of the most important things that we do in algebra is factoring. And the reason is factors can do so many things. Factors under radicals can be simplified. Factors and fractions can be simplified. Factors actually make calculus easier to work with. We do something called partial fraction. Everything is built on factors because they're so flexible. Terms are added and subtracted. We don't like terms that are added and subtracted because we can't do much of anything with them. So I want to do a quick review of factoring, because if you can factor, you can probably solve most any other algebra problem. So let's factor 6x squared. I lost my place. Plus 7x minus 3. There are lots of methods people use to factor. They do factoring with the AC method, factoring by grouping, factoring by the guess and check method. Lots of different factoring tricks. My favorite factoring trick is what's called slide and divide. So let's do a little bit of slide and divide to factor this, and then we'll come back and take a look at some basics of matrices. I saw that question just come in the chat. The idea of slide and divide is this might be hard to factor the way it looks. So we're going to slide the 6 over to the 3 and multiply them. So we have x squared plus 7x, and when the 6 slid over, 6 times 3 is 18. That's going to give us an equation that's going to be easier to factor. So we're going to factor the easier problem and not worry about the actual problem. When I factor this easier problem, we're looking for something that multiplies to 18 and adds to 7. Well, 18 is 9 times 2. And if the 9 is positive and the 2 is negative, that will give me that positive 7 in the middle. So just with a little guess and check, we've got it factored. But something to remember is this is the factored form of the easier problem. It is not the factored form of the original problem. To get the original problem, I said this method's called slide and divide. So we've done the slide of the 6 where we slid it over into the 3 to make 18. Now we need to divide it out. So I'm going to divide each of these numbers by that 6. When I reduce these fractions, whatever's left in the denominator is going to go in front of the x. So 9 over 6 reduces to 3 halves. The 2 goes in front of the x. It's 2x plus the 3. When I reduce 2 6, that's 1/3. The 3 left in the denominator goes in front. And the 1 left over goes here. And now we have factored the more involved problem that's up above it. So that's slide and divide. Hopefully that helps with some of your factoring tricks. I am seeing lots of great questions come in, though. So we need to move away from factoring. And I mentioned we were going to do a little bit of basics with matrices. Then we'll come back and do some quadratic equations and maybe some more polynomials, logarithms, exponential functions, and more of that coming. So Make sure you are staying here. Scan this QR code so you know when we're going to be doing more tutoring topics coming up next week. But let's take a look first at basic matrices. And then we'll come back and do some circles, logarithms, exponents, polynomials, and other stuff. All right, matrices. Let's do some matrix multiplication. Let's go 1, 2, -3, -1, 2, and -4. That matrix has 3 rows and 2 columns in it. We can multiply this by any matrix that has the same number of rows as this has columns. So let's do 2 rows. And let's do 1 column just to keep it easy. Otherwise, we're going to be here all day. So 2 rows, 1 column. Maybe I do 5 and 3. When I do this, when I multiply matrices together, the middle numbers of the dimensions have to match, and the answer is going to have the dimensions of those outside numbers. So we're going to end up with a 3 by 1 matrix. So what we're going to do is we're going to take rows from the first matrix and columns from the second matrix and multiply them together. So we've got 1 times 5, which is 5. Plus 2 times 3, which is 6. Then we'll go to the second row and multiply it by the first column. -3 times 5 is -15, and -1 times 3 is -3. Then we'll go to the third row times the first column. 2 times 5 is 10. -4 times 3 is -12. Then we would kind of repeat that process. If there was a second row, we would do first row times second column and put it here in the first row, second column. Then second row, second column goes in the second row, second column, and so on. But here we're done. We just have to do the arithmetic. 5 plus 6 is 11, -18, and -2. That's the product we get when you multiply these 2 matrices together. Excellent. So many great questions coming in. We did factoring quadratics, but what about the quadratic equation itself? Let's take a look at some quadratic equation problems. Let's do x squared minus 4x equals 7. And we want to figure out what are the solutions for x here. Now, whenever you're doing an algebra problem that has x squared and x in the same problem, pretty much always the strategy is it needs to equal 0 first. So we can make it equal to 0 by subtracting 7 from both sides. When I do, we get x squared minus 4x minus 7 equals 0. And then ideally, we would take a look at this and try to factor this expression. The problem is it doesn't factor. There's nothing that multiplies to 7 and adds to 4. So we need a different strategy. And that different strategy is the quadratic formula, which, by the way, yes, you need to take the time to memorize. It's never going to go away. It comes up constantly in your future math classes. There are lots of great songs to learn it if you like a song. So if you like Mary Had a Little Lamb, Mary had a little lamb. All right, so you got opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I am not a singer. I'm a mathematician. Don't judge me. If you like Farajaka, you've got opposite of b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a. However you can remember, please take the time to learn the quadratic formula. It's going to be very useful to you in your math classes. So what are a, b, and c? A is the number in front of x squared. If there's nothing written, that number is 1. B is the number in front of x, and c is the number that doesn't have an x on it. So for our problem, we're going to say x is equal to the opposite of b. The opposite of -4 is +4, plus or minus the square root of b squared, which is -4 squared, minus 4 times a, which is 1, times c, which is -7, all over 2 times a, which in this case is 1. And now we're just doing some simplification of this algebraic expression x is equal to 4 plus or minus the square root of negative 4 squared is 16. Be careful with your signs. Negative times a negative is a positive. Also be careful, we've got a negative times a negative, making these both positive. So it's going to be plus 4 times 1 times 7 is 28. All over 2 times 1 is 2. Go ahead and add these numbers together. X is equal to 4 plus or minus the square root of 44. All over 2. Usually we're stuck here. Sometimes you can simplify the square root. And in fact, this time we can simplify the square root. So let's go ahead and do that. 44, that is 4 times 11. And I can take the square root of 4. The square root of 4 comes out as a 2. So x is equal to 4 plus or minus 2 root 11. That's what's left. All over 2. And actually where this becomes really, really nice is I can do some simplifying. But be careful. Do not cross these 2's out and say you're reducing. Because we cannot reduce terms. We cannot reduce things that are added and subtracted. This is why we spend so much time on factoring, because factoring we can do things with factors. We cannot do things with terms. We can do things if there's multiplication. We cannot do things with the addition and subtraction. So what we want to do is we want to factor out the common factor of the numerator, which is 2, leaving behind 2 plus or minus 1 square root of 11 over the denominator of 2. And now that that 2 that has come out has been factored out, it's a factor. Now I can reduce it. And so we end up with our answer of 2 plus or minus the square root of 11. I will add that the quadratic formula is probably one of the more difficult ways to solve a quadratic because there's so many spots that you can make a small error in. You can make a sign error, you can make an error in the formula, you can make an error in simplifying the radical, in reducing the fraction. So a way that I like to solve better, and it's wildly unpopular because students don't like to learn this new method, but this new method is actually easier if you just take the time to learn this method. It's completing the square. Let's go all the way back. Completing the square says if I can make this left side into a perfect square, it's going to be very easy to factor and solve. Completing the square is always easy if A is 1 and B is even. That's exactly what we have here. So B is that negative 4. To complete the square, we'll take half of that B, half of negative 4, which is 2. And then we square the answer. 2 squared is 4. We're going to add 4 to both sides of this equation. Because when I do, this left side is a perfect square. The square root of x squared is x. We take the sign from the middle, and the square root of 4 is 2. That's equal to 11. And then I just have to go after the x by taking the square root of both sides. The square root and square undo each other, so we have x minus 2 is plus or minus the square root of 11. And then to get the x alone, I just add 2 to both sides. Then I get x is equal to 2 plus or minus the square root of 11. And we get that same answer we had before. A lot fewer steps, a lot cleaner, a lot quicker. Completing the square is easier if A is 1 and B is even. It's easier than factoring. It's easier than quadratic formula. Take the time to learn completing the square. It's a nice little trick. All right. You have been waiting so patiently to do logarithms and exponential functions. So there's lots of things we can do with logarithms and exponential functions. One is we can try and solve equations with logs. Another is we can try and solve exponentials with logs. So which way do we want to go? Maybe we want to go both. We got time. Let's do both. Let's solve the equation 2 to the x equals 3 to the x plus 1. Logs and exponents are inverse operations, which means if we can't solve a log equation, we're going to change it to an exponential equation. And if we can't solve an exponential equation, we're going to change it to a log equation. That's the general strategy to solving these, and it almost always makes it into something nicer and easier to work with. So if we have exponents, we can take the log of both sides. And I'm going to do the natural log of both sides. You can do a log base 10 if you want. The reason I'm doing natural log is I'm lazy, and natural log has 2 letters and log has 3 letters. That's it. But you can do a log if you want. You just have to write 3 letters every time, and I'm going to write 2 every time. The nice part about logs is they have this nice property that if there is an exponent inside of the log, that exponent moves out front. So this becomes x natural log of 2. That exponent can move out front. So it's going to become x plus 1 natural log of 3. Now, natural log of 2 and natural log of 3, those feel weird because we're not used to seeing them. But remember, we can put those in our calculator. Those are just numbers. They're weird numbers. They're ugly numbers, but they are just numbers. So I can still solve this like always. We need to get at the x by getting rid of the parentheses. So I'm going to distribute through the parentheses. So we have x natural log of 2 equals x natural log of 3 plus 1 times natural log of 3 is the natural log of 3. I want to have all the x's on the same side of this equation. So we're going to subtract anything that has an x on this side, move it over to the other side. If there was anything over here that didn't have an x, I'd move it over to the right side. But now I have x ln of 2 minus x ln of 3 is equal to, those are gone, the natural log of 3. We're getting closer. We've got to get these x's in one spot. Now that they're all on one side, it's nice that we can factor them out as a greatest common factor, leaving behind the natural log of 2 minus the natural log of 3, still equal to the natural log of 3. Finally, to get the x alone, it's x times this ugly thing. It doesn't matter what that thing is. To get the x alone, we just have to divide by that ugly thing. So if I divide both sides by that, natural log of 2 minus natural log of 3, same thing on both sides. We get that x is equal to the natural log of 3 divided by the natural log of 2 minus the natural log of 3. And that you can put in your calculator to get an answer to this equation. Now, a word of warning, on your calculators, whenever you hit the natural log button, it's going to open a parentheses. And so that can mess things up if you don't close your parentheses. So make sure when you're done with the log number, you close the parentheses after that. The other thing you need to watch out for is if there's more than one thing going on the top or the bottom of the fraction, that needs to be in parentheses so that your calculator knows that whole thing goes in the bottom, not just the first term. We would have to do the same thing on the numerator if there was like a number or another natural log up here. There's not in this case, but you can plug that in your calculator and get a decimal equivalent, or maybe your instructor wants to have you leave it as that exact answer. Ask your instructor what form they are looking for. So we had an exponential problem. We solved it with logs. I mentioned we can also go the other way. So let's look at a log equation, and we're going to solve it with exponents. This is your live office hour with Chegg here every week at this time. Make sure you're scanning the QR code in the top corner here so that you don't miss any future lives. We're answering your questions. Stick them in the chat. Let me know what your questions are. Ooh, great question came in. Could I simplify that to the natural log of 3/2? Yes, that is a property of logs. You can do that if you want. The directions didn't specify, so it doesn't really matter. Either way would work. We're going to solve the log equation that log base 4 of x plus 3 plus log base 4 of x minus 3 equals 2. And I love that you just brought up those log equations, Eve on TikTok there, because we're going to use some of those log equations to help us solve this problem. Logs are difficult to solve for when there's multiple logs going on. But what's nice is we can condense the logs into one using the properties of logarithms. when we're adding two logs together, what we end up doing on the inside is multiplying these logs together. So we'll do x plus 3 times x minus 3 and multiply those insides together. This comes from a familiar exponent property, that a to the x times a to the y. We know we can take those exponents and we can add them. Oops, that's not this property. Let me try again. It's the other exponent property. If we've got some number raised to the x, no, that was the right property. Confusing myself. Logs are exponents, so we've got a to the x times a to the y. That's equal to a to the x plus y. If these exponents are added, it means the bases are multiplied. If these logs are added, it means their insides are multiplied. That comes from the same thing. The proof of this property, it actually uses that relationship. So when we have two logs that are added, we can multiply their insides or their guts together. And then what we can do is, now that it's written as a single log, and we can't solve it as a log, well, what do? We change it into an exponent. So 4 is the base of the log. 4 is the base of the exponent problem. 2 is the exponent. Logs equal the exponent. So what the log equals, that's the exponent. And it's equal to x plus 3 times x minus 3. I'm going to go ahead and multiply that out. When we do, we get x squared minus 9. And let's go ahead and multiply out 4 squared. That's going to be 16. Then all we have to do is solve for x. Let's go ahead and there's two ways we can go. Let's set it equal to 0. Subtract the 16 from both sides. Negative 9 minus 16 is negative 25. You might recognize that as a difference of squares. So it's going to factor to x plus 5 times x minus 5. And we know that if it equals 0, one of these factors has to be 0. So either x plus 5 equals 0 or x minus 5 equals 0. And so we'll subtract 5 to get negative 5, add 5 to get positive 5 for our solution. And under normal circumstances, we'd be done. There's something we got to be careful of with logarithms. What we have to be careful of with logarithms is what is inside the logs, this stuff and that stuff. What is inside the log has to be positive. Logs are not defined, at least not on the real numbers. Logs are not defined at negative values. If I put negative 5 in here for x, negative 5 plus 3 is negative 2. That has a negative value. Cannot happen, so we throw it out. What about the 5? 5 plus 3 is 8. It's positive. We're good. 5 minus 3 is 2. It's positive. We're good. So actually, the only answer that works for here is the answer of 5. If x is 5, this log plus that log will equal 2. So logs and exponents. If you can't solve the log problem, change it to an exponent problem. If you can't solve the exponent problem, change it to the log problem. That is really how we want to handle those. Excellent. Great questions coming in. Remember, this is your live office hour to look at algebra and pre-calculus content, answering your questions, helping you out to be successful in your classes. So don't be shy. Use the chat. Tell me what you're working on in class. Tell me what questions you have, and we can look at it. One question came through about wanting to look at the AC method for factoring. So let's go ahead and do that AC method for factoring. Let's try and factor 7x squared plus 15x plus 8. Is that factor? I think that's a typo. I'm not sure if that one's going to factor. Well, let's see. Minus 8, maybe. Let's see what happens. Maybe I got a typo. All right, the idea of the AC method, it's really similar to the setup of the slide and divide that I talked about earlier, is we're going to multiply A times C. We're going to multiply those two together. 7 times -8 is -56. And we're going to look at factors of 56. 56 is 1 times 56. It might be 2 times 28. 3 doesn't go into there, but 4 does. 4 goes in there. 1 and 4, 14 times 5 doesn't go in there. 6 doesn't go in there. 7 goes in there. It's 7 times 8. Yeah, this one doesn't factor. I didn't think it factored. Let me try a different problem. Please hold for a mathematical error. Let's try a different problem that might factor a little better. Let's try this one. See what happens with 5x squared minus 19x plus 12. Let's see if this one factors better. Hopefully. If I mess up 2 times in a row, we all get to go home. No, I'm just kidding. We'll just find something that works. All right, so we'll multiply A times C like last time. We get 60. 5 times 12 is 60. So then we look at how 60 can be broken up. 60 is 1 times 60. It's 2 times 30. It's 3 times 20. It's 4 times 15. It's 5 times 12. It's 6 times 10. 7, 8, and 9 don't go in there. So those are kind of all of our options to multiply to 60. One of these options, hopefully, we can use to add up to get that middle number of -19. And sure enough, we do have one option. Did you notice that 4 and 15, if they're both negative, could give us -19? So we're going to split up this -19x into -4x and -15x. We still have the plus 12 at the end. We still have the 5x squared at the beginning. And that's going to split it up into something that has 4 parts so that we can cut it in half and factor out the 2 sides separately. The greatest common factor on the left side is an x, which leaves behind 5x minus 4. The greatest common factor on the right is 3. But I'm also going to take this negative with it. So -3. And when I do, I'm left with 5x and a minus 4. If you did this correctly, every single time, this parentheses stuff, we call that a binomial, that will match exactly. If one's positive and one's negative, something went wrong. But if they match exactly, you've done this right. That's going to be your first factor that you'll factor out, 5x minus 4. And the other factor is what's left, the x minus 3. And so that's kind of the premise of the AC method in order to factor. Excellent. Lots of great questions coming in. Let's do some complex numbers. We haven't talked about complex numbers yet. We talked about those in my last hour as well. But at a pre-calculus algebra level, we use complex numbers quite a bit. What is a complex number first? The idea is if x squared equals -1, we want a solution for x. And so how do we get the solution for x? We'll take the square root of both sides. And x is equal to the square root of -1. But what squared is a negative number? Every squared is positive. So what we had to do in mathematics is come up with something that makes this work, that doesn't break all the other rules of mathematics. And so we have defined it as I. So I is the square root of -1. That's where it comes from. So whenever you see the letter I, just know that's a placeholder for the square root, the proper square root of -1. With that said, we can take numbers that have a real part like 5 and an imaginary part like -2 of these square roots of -1. And we can multiply it by another complex number. Maybe we're going to multiply it by -1 plus 3i's. Well, what's nice is, like I said, defining I as the square root of -1 doesn't break any of the other rules of mathematics. So all the other rules still apply. and they still work. In other words, we can actually multiply this out using FOIL just like we always have. So we can distribute the 5 onto the -1. 5 times -1 is -5. We can distribute the 5 onto the 3i, just like if this was a variable. 5 times 3 is 15 of these i's. We can distribute the -2 on the -1. Negative times a negative is a +2 of these i's. And -2 times 3 is -6 of these I squares. Now, this is the only place that you kind of have to be aware of. The big thing about I is the square root of -1, but more specifically, I squared. If you square both sides, squaring gets rid of the square root. I squared is -1. So this I squared can be replaced with -1. But if that's -1, we have a negative times a negative, which makes it a positive. So I'm going to erase the I squared and change the sign, because that's essentially multiplying by a -1. Then all we have to do is combine like terms. We've got a -5 and a +6. That's 1. And we've got a 15i and a 2i. That's 17 i's. And now we've multiplied two complex numbers together. The answer is going to be another complex number. But again, everything still works exactly the same. What questions do you have that you want to take a look at in our pre-calculus and algebra review? Ooh, great question coming here about complex numbers. Is I only for the negative numbers or just -1? Great question. We want to make sure we're careful. We don't want to say I is -1. I is the square root of -1. That's very different. And then we can get some cool things that happen with the exponents on I. So I is just I. You can think about that. I is the square root of -1. It's only the square root of -1. It's always the square root of -1. But what's neat is if we square both sides, or actually let's just think about it as multiplying both sides by I. If I multiply I by I get I squared. Well, if I square this square root of -1, squaring gets rid of the square root, and we get -1 as an answer. So I squared is -1. I is not -1. I squared is -1. But then what's cool is if I multiply both sides by I, we end up with I cubed, and -1 times I is -I. Then look what happens when we multiply by I on both sides again. Multiplying by I on both sides, we get I times I cubed. That's I to the 4th equals -I times I, which is -I squared. Well, I squared is -1. So instead of -I squared, we have -1, and a -1 is a +1. And then you can kind of see the cycle is going to repeat itself. If I multiply both sides by I, we get I to the 5th, which is going to be a basic I. And then I to the 6th, multiplying by I again gives us I to the 6th, which is the same as I squared, which is the same as -1. If I multiply by I again, I get I to the 7th, which is the same as I cubed, which is the same as -I. And then we get I to the 4th, which is not I to the 4th. 7 plus 1 is 8. I to the 8th is the same as I to the 4th, which is equal to 1. So we end up with this loop. We end up with this circle that has 4 steps to it. That is what's going to allow us to take I to any exponent. Let's take it to the 75th power, and we can simplify this down to something that does not have an exponent. Knowing that this loops with a period of 4 pieces to a loop, right? We can take 75 and divide by 4. So we see how many times we're going to loop through the whole thing. 4 goes into 7 once, subtract 4, 35. 4 goes into 35 8 times, subtract 32, and I get 3. We get 18 with a remainder of 3. What that means is when we go 75th power, we're going to go through this loop 18 times. And then what we really care about is we care about the remainder of 3. That means this is going to be the same thing as I cubed. We're going to go through 3 individual steps. I cubed is negative I. And so I to the 75th is the same as I cubed, which is the same as negative I. So every single exponent on I can be simplified down to something that does not have an exponent. Kind of cool. So that's complex numbers. We are just about ready to wrap up, but I think we've got time for one more problem. So let's do a problem with some radicals. That's a topic that we haven't hit on yet. Let's solve a radical equation, which just sounds cool, like radical man. You know, sometimes in algebra class, sometimes we're radical, sometimes we're rational, sometimes we're complex. Oh, the puns, they fly, they fly. Let's solve the equation x minus 1 equals the square root of 7 minus x. Radical equations. Well, the way we solve an equation is we're going to do the opposite operation to get rid of it. So we're going to do the opposite operation of a square root. Well, the opposite of a square root is to square. So we'll square both sides. Because square undoes square roots, and that's equal to 7 minus x. But be careful over here on the other side. We cannot, should not, will not, never will distribute that 2 and call that x squared minus 1 squared. That's bad. Don't do that. The reason is squaring means we multiply it by itself. So really that means x minus 1 times x minus 1. And if you distribute that through, we find out there's this middle term that you've missed. You end up with x squared minus 2x plus 1. Some people like to do the shortcut that we just square the first term, multiply them together, and then double it, and then square the last term. That would work as well, but please be careful. It's not x squared minus 1. It's x squared minus 2x plus 1. All right, to finish solving this, we need to set it equal to 0. So I'm going to add x to both sides. I'm going to subtract 7 from both sides so that it's equal to 0, because equations are easier to solve when they equal 0. And now we have x squared minus x minus 6. That one factors quite nicely, actually. It's going to factor to x minus 3 times x plus 2. And then we can set each factor equal to 0. X minus 3 equals 0, so we add 3 to both sides. X equals 3. X plus 2 equals 0, so we subtract 2 from both sides. X equals negative 2. The thing we need to be careful of, though, with square roots is square roots can never equal a negative number, at least not with real numbers. I know we just talked about complex numbers, but that's not going to be allowed. So I need to test, when does this square root equal a negative number? If x is 3, 3 minus 1 is 2. That's fine. If x equals negative 2 minus 1 is negative 3. The square root will never equal a negative 3. Square roots cannot be equal to a negative number, so we have to throw that one out. And it turns out the only answer that works here is going to be x equals 3. The other one, we call that an extraneous solution. It has to be thrown out. Well, can you believe how the time has flown during our time together? We are already at the end of our hour. If you haven't taken a look at this QR code yet at the top corner, scan that QR code so you have our schedule for future weeks, because I want to make sure you can log in. We do pre-calculus and algebra reviews every week. We also do calculus reviews, trigonometry reviews, but also there's other subjects as well, such as economics, chemistry, physics, linear algebra, and more. So please take a moment to do that. Of course, at Chegg.com. Check us out. We're here to help you 24/7 to be successful in your toughest subjects with many resources, including expert answers, more of these live sessions. And be sure you're following us on TikTok, on YouTube, on Instagram, on Twitch, on all of the things. And of course, be following me as well at Wallace STEM on all those same channels. I am excited you've been able to join us for this live. I look forward to seeing you next week. So make sure